Right. Hi. All right, I'm conscious I'm the only thing standing between you and the Wazero party. So let's crack on. All right, so we've talked a bit over the last couple of days about Spin. Spin is a event-driven microservice runtime for WebAssembly. It is very much based on being driven by incoming events. It's reactive. And obviously, one of the main microservice protocols is HTTP. And Spin has got HTTP built in. We've seen that. Towlson showed us that. That's all good. But what if you want to do something other than HTTP? Well, Spin has got Redis built in as well. So if you want to do, say, queuing applications, you've got some options there. But there's a lot of stuff that is not HTTP. There's gRPC. Well, OK, gRPC is sort of HTTP, but it's also sort of not. You don't really want to think about it at that level. There's cron events, just timer events, queues, which you may need to poll, for example, storage events, database triggers, blob storage inserts, file changes, event streams, video streams, things like that, or alerts coming out of a monitoring system. And all of these might be things that you want to have Wasm logic processing. These might be events that you want to handle in your service. You want to be able to respond to. And some of these are available via webhooks. For example, if you want to react to Slack messages, you can implement that as a webhook. There are some issues with that. We won't go into those. But a lot of things you can't do via webhooks. And for that, you need custom triggers. And just to give a comparison, AWS Lambda, which is kind of, I guess, the reference point for functions as a service, I printed out their list of the events they could respond to, and I got through quite a bit of paper that way. So, back to Spin. When we've talked about Spin, we've kind of talked about it as a bit of a monolith. If you've seen our demo out there, you run Spin up, and your application starts serving. You've got an HTTP URL. You can start using that. It looks like there's only one thing going on there. I'm here to tell you that's not true. There's all of two things going on. So when Spin is running a service, it kind of falls into two parts. There's Spin up, which is the loader. The loader kind of takes care of parsing the application manifest and assembling all of the assets and preloading all of the Wasm files and all of that good stuff. But when it's done that, it gets out of the way and calls another subcommand called spin trigger. So there are two processes involved. There's spin up, the loader, and spin trigger, which is the host. And spin trigger is where your user code runs. And spin trigger is also what listens. Now, I talk about spin trigger as if it was one thing. It's actually various subcommands. It could be the HTTP one or the Redis one. Spin up kind of doesn't care. All spin up wants to do is load the application, parse it into something that looks familiar to triggers, and throw it over the wall. There's a contract between these two parts. And spin up doesn't care what it's throwing things over the wall to. All it cares is that it's fulfilled its part of the contract. It's flung this application object over the wall, and hopefully something is going to pick it up. It's going to call something. By default, it will call spin trigger HTTP or spin trigger Redis, but you can also put in a spin plugin. And a spin plugin can be any program. It can be anything you want to write. It needs to be registered with Spin. For triggers, it needs to have the magic name trigger-type. But other than that, it can be anything. Now, you don't want to fulfill that contract yourself. The app object is a bit of a fiddle to work with. It's a big JSON file. And so we provide helpers, which you're seeing at the top left there, that will help a custom program load all of that stuff and kind of get it ready so there's an engine standing ready for you at the bottom right, ready for you to put events into. Just to stand aside from that model for a moment, the spin runtime doesn't have to run inside spin trigger or something that uses the trigger infrastructure. It doesn't have to be triggered by spin up. All you actually need is an application object that you can feed into the loader infrastructure and get a spin runtime out of it. So you could host the spin runtime, for example, within a database or within a blob storage engine, and it could process events there without a separate spin binary. But what we're going to do, we're going to look at it in the context of the spin up spin binary. So a little more detail about that contract. The thing that gets flung across, the application object, it's a file called spin.lock. Unless you're doing something quite manual, you shouldn't need to know that. Our infrastructure will take care of loading that for you. You might also need to pass command line flags because the operator, the person running the program, may want to configure, for example, a security token or address on which to listen. Those will get passed through to your trigger program. And then in your trigger program, you'll want to implement some protocol-specific code that listens for events and passes them on to the spin engine, which will then dispatch it to the guest code, which runs the application, the business logic. And there's going to be a couple of schemas involved here. Often they'll be very similar, but they're not necessarily the same. So your source, your event source, whether that's HTTP or Redis or SQS or cron or whatever, that will define what an event looks like to it. And you can't control that. So you're going to have to accept that source-defined schema. You'll also have a WIT file, a Wasm Interface file, that defines what's going to be handed into the spin engine and what, therefore, guest application code needs to implement. In the same way that in, say, the spin HTTP scenario, there's a well-defined Wasm interface that all HTTP modules have to implement. You'll define one for your trigger as well. And therefore, you've got that transformation step in the middle. All right. As a famous man once said, talk is cheap, show me the code. So let's see how we do with this. Is that readable to folks up the back? Bigger? Is that okay? All right. So, what does a trigger look like? Well, at the moment, custom triggers have to be written in Rust. We only offer Rust bindings for the spin engine, and that kind of propagates outwards. So a trigger starts out as just a plain Rust program, nothing complicated going on there. I will flag one thing that's going on here. Because we're going to need to make a spin plugin out of it, we're going to need to generate a plugin manifest, which looks like that. I don't want to write that by hand. It's very tedious. So there's a little tool that I can use to build plugins and plugin manifests from a binary, which I'm going to call from my makefile. But really, you can see what's going on there. Cargo build to build that Rust binary, and then spin pluginify and spin plugins install to register it as a plugin with Spin. It does need to have that magic name. Now, my original plan for this was to implement the finger protocol, the old Unix finger protocol. And I was thwarted, not by any well, I was thwarted because I couldn't find any clients that worked on ports other than 179, and the Mac wouldn't let me run on port 179. So instead, you get kind of sub-finger protocol. The finger protocol is basically one line of text sent over a TCP connection, one line of specially formatted text sent over a TCP connection. My trigger is going to be more generous than that. It's going to set one line of text sent over a TCP connection, and it can be anything you like. So it's just really a very simple TCP handler. It's not a real-world handler. I'll show you some examples of those later on, but this one is not a real-world handler. All right. So let's add some stuff to that. So now let's start building out that trigger. So we're going to have to add some stuff to cargo.toml. The things that are particularly relevant here are spin core and spin trigger. Those are, spin core is the bit that's going to give you the actual spin engine, the bit that runs your user's Wasm code. Spin trigger is the bit that helps with loading that application object and getting everything into a happy and comfortable shape ready for you. And now we can look at, we can look at the source, and that's grown a bit as well. Now, we're now importing a WIT file. We're importing a WIT file. I always get the import and the export mixed up. We're importing a WIT file. That is the signature of our guest code. And let's look at what that is. That's going to be pretty simple. So it's just handling a single line of input, and it's going to return a string. And because this is a finger or telnet style operation, the string will be just returned to over the same TCP stream that the message came in on. We've then got some incantations, and this is something that's generated by the Wasm time import, and this is a thing that Wasm time needs. And in our case, at least, they're not doing anything particularly exciting for us. In other scenarios, they might, but we won't worry about that. Now, we might want to have, say, command line arguments. I couldn't think of a good one for this, so I put in the host. This is just something that will now appear on the command line. If somebody wants to run this at a particular address, they'll be able to go spin up -- host, whatever the address is. And that will get passed through to the trigger. Now, where the magic really begins is in this command. So this trigger executor command is something that comes from Spin. That's basically saying, I want to make this I want a clap command, a clap application. So that's going to be handle parsing all of the all of the command line arguments that Spin passes through to it. I want it parameterized by the kind of trigger that's going to run. So in this case, it's TCP line trigger. And now, in main, we are going to hand off to that command. We're going to ask that command to parse the command line and then run. And the run method is provided by that trigger executor command, and that then goes away and handles all of the heavy lifting in terms of the application object for us. And what it's going to do is it's going to then hand off to that trigger type, an instance of that trigger type that we specified within that generic argument. So, what happens next? Well, what that's going to take us to eventually is going to be this TCP line trigger, the impl trigger executor of that, and it's going to bring us in at new followed by run. But before we can get to those, there's some other bits we need to look at. Some of these are formalities. These are things that map to stuff in the command line, in this case. And this is stuff that maps to the stuff that goes on in the spin.toml. So now if I look into my guest, it's got a spin.toml. What do I want to parameterize? Well, really, I only care about the port that it's listening on. So if I now go back and look at that type, you'll see that's got a component, which is the component ID, the spin component ID, and it's got those things that live in that component.trigger section, which in our case is only the port. That's the only thing that's in there. What else have we got in here that's interesting? This is, in our case, this is not, I'm afraid, interesting, but in other cases it may be. So I'll just give you a quick that basically maps to the application level trigger section. In this case, we don't have any additional options on that, but if we did, as for example in HTTP you've got a base URL, then that would need to be mapped into the trigger metadata. And then we have the trigger itself. The trigger itself is really up to you as the implementer, but what you'll typically need to hold is a trigger app engine, which we'll see that being provided to us by Spin, by that trigger command executor, and the component settings, which is pretty much that mapping from component ID to the per component trigger values. All right. So now we can go back and have a look at those new and run functions. So what do? So new is responsible for instantiating the trigger instance. And what's that got to do? It's got to load those component settings, which it can get from the engine.trigger configs, and it's going to have to stash the engine and those settings. What we're doing here is it could all be got from the engine every time, but it's convenient to kind of parse some of it out and just have it ready in a convenient format for when you run. So this just instantiates the trigger, and then trigger executor command will call run, which is where the good stuff happens. So in our case, what happens here? Well, we need to set up some Control-C handling so that we don't get threads dangling. And then for each component, we want to start listening on that component's port. We need to be careful to do this asynchronously. I often find myself moving things out into functions that don't borrow self because lifetime's an async and it all gets very, very hairy. So this is the pattern that I found works best for me. So I'm just doing an iterate over that collection of component settings. And losing my place, sorry. Not too au fait with the Mac. So I'm iterating over that set of component settings, just capturing the port, building the address, and then spawning a loop that listens. And then I just want to do a join all on, or select all on those. I want to wait for the first one to finish. And as soon as one of them finishes, my trigger is no longer sort of doing what it needs to do, so I just drop everything, exit. And this has got implications for your error handling. You don't want one error to bring down your whole trigger. I'm not going to show you correct error handling. I'm going to show you dangerous error handling. But in reality, you need to be careful about that. And then the actual listening is very specific to your application. In my case, I'm copying what Oscar did, really. I'm creating a socket, binding a socket, listening on that socket, and just looping around, accepting requests, and processing those TCP streams, just grabbing out the first line from that stream and passing that to the handler, and then writing whatever response I get. And the handler is where the Wasm magic happens. We prepare an instance of the engine for the particular component that we've decided to route this thing to. We new up an instance of the thing that we imported, this TCP line thing, and then we call the entry point, and that goes into spin and dispatches to the guest code. So now we can look at some guest code. We'll just look at a simple one. And what does this have to do? The main job is that it now has to export the same WIT file that the trigger imported, so that everything matches up. And in the Rust case, that will mean that will then ask you to implement a struct, which we have nothing interesting to put in it, and implement this generated trait for that struct. And that trait has got an appropriate function in it, which is the thing that's going to get called. So let's give that a go. Let's make test. So that's building the trigger. And it's then going to pluginify it. And that's installed the plugin, and that's also now built there's two modules that I've got, two guest modules that I've got. It's built those, run spin up -f, and we can see it's printed out a message. That message has come from the trigger that it's listening on those ports. So I can now find my terminal and telnet localhost 8089. Hello, Wasm.io. Hola from Barcelona. And lest you worry, that is just a canned string. We also have a fancy listener, which I put hello doggy into there. It's going to go off and get me a random dog fact from the standard Fermion demo API. As an employee, I'm required to use that endpoint in all of my demos. All right. So, what did we see there? We saw the source schema, which was a bag of bytes. It was a TCP stream. We imposed some structure on that. We parsed that into the representation that we were interested in, a line delivered over TCP. And then we handed that off to the spin engine, which dispatched it to our WebAssembly code. So, It's going to take me a while to work my way through this list. But with these sort of techniques, we can start to build out that broader ecosystem for different kinds of microservices, different events that can drive microservices, different events that our applications, our Wasm applications can react to, and perhaps point the way to an open source functions as a service built entirely with Wasm. Thank you very much for your time. And we've got a few minutes for questions. I knew Ralph would have a question. Is this the one about which bit was fun?
No.
Right.
So I was wondering if you had a chance, if it was possible, if you could see some of the error handling code that you referred to as being more production oriented, as opposed to what you were demoing here, just to get an idea.
Sure. So if I wonder if this link will work. Oh man. So, gosh, all my booth shifts. I'm sorry, Sarah. So I don't know if I can zoom in quite enough on this, but if this is an SQS trigger, and if we look in here, it's following a fairly similar structure, except that for a start, nothing unwraps, because unwrapping basically dooms you from the start. But also, if I look at my loop here, my receive loop here, that is returning a join handle of something called termination reason, rather than a Rust result. And termination reason it's very much like a result, except you can't get to it by question marking. So there's no way, or it's not easy for that code to return something or to do something just by somebody falling into normal habits that will return an error that will then cause the loop to exit. So the loop will go round and round and round, and each iteration will return a termination reason that should be sort of something like, no, you're good, go ahead. Or if it really sees something disastrously wrong, it can return a reason saying, no, fatal, take the whole trigger down. And at that point, it will start bubbling up. So that's I mean, there's also, you want to do logging and stuff like that, which I think is not even in this sample. But I'm sure I don't need to tell you how to do logging. But that's the kind of thing I'm thinking of. It's very easy in Rust to just propagate errors. And if you propagate an error all the way up to that outer collection, that outer select all, then that will exit and that will end your trigger. Does that answer your question?
Yeah, more or less, yeah.
Cool.
I've got to think about it more.
Oh, yeah, we all need to think about it more. I know I do. All right, any more questions? Is that a no? All right, thank you very much indeed. Have a great evening.